Hey, this is video 2 of how does the internet work from a web development perspective. If you're just jumping in now, go back and watch video 1. I'll put links around for that. And let's get into what does the server world look like from a web development perspective? How does the internet work from the back-end perspective of the internet? So we narrowed it down. The basis of the internet is browsers or clients, sometimes they're called clients, are making requests to your server, and my server is going to post back responses. My server is 100% responsible for what those responses are. You could say, give me google.com, and my Google server could give you an image, right? You could say mysite.com, and my site could just give you back a CSS file every time. I'm in control of what happens. Let's look at how that actually works. Let me go ahead and drag over. Don't get confused here if this looks a little freaky. This is what I will call a basic website server configuration. Now, there are tons of different kinds of server configurations. If you went to, say, HostGator and sign up for a website package, you're going to get what's called a cPanel. cPanel sits on top of your server. It's software that manages some things for you. And here's what it's setting up for you, is they're going to set up an Apache web server. You're going to get probably a LAMP machine. LAMP it's running Linux. It's using Apache for the web server, MySQL for the database, PHP for the backend language. This is kind of the most popular for anything up to enterprise or, anything up to professional level stuff. If you want a basic website, this is the way to go. It's just easy. Apache as a web server is very flexible. It can do a lot of stuff, but what it's most often used for is just basic serving up of files. Websites, we call them. So here's what Apache does. Apache is the web server program that runs on your server. This square here represents this machine. So this is my machine. This is an actual computer plugged into the internet with an IP address. And so Apache is set up to listen to port 80. Now don't freak out, I just said port. What port 80 is that's the default HTTP port. So if I went to HTTP:// if I could spell, if I went to that IP address, it's the same as going to that IP address :80. So the :80 gives it a port. I can request port 3000, but by default, it's basically going to request port 80. So the reason your computer has an IP address, but you can't go to that IP address and get your files, is you don't have a web server program running. It'd be very dangerous if anybody who accesses your IP address can just surf your computer. That's terrible. So a web server runs, and it will listen to requests, and it will kind of have access to certain parts. So Apache is set up to listen to port 80, and you configure different hosts to different folders. If you remember from our example here, I'm requesting google.com no path. So when I request that, my browser actually goes to the DNS lookup. The DNS lookup sends me to my server. So my server just gets a request to the IP address now, but it still knows from my headers that you're looking for google.com. So Apache knows, mysite.com. Well, mysite.com, let's look in the sites/mysite.com/www folder. And so the basic Apache configuration is just going to serve you files from that folder. That's it. No smart stuff. It's just going to give you files. So when you say mysite.com, it's going to go to the folder that's configured for that website, and it's going to give you the index.html if it exists, or the index.php if it exists. That's pretty much your basic configuration. So you could configure 10 different websites, mysite.com, yoursite.com, oursite.com, and you could make them all look to this folder. Or you can make yoursite.com look to another folder on your computer. You can make oursite.com look at this folder. And so that's kind of, Apache can serve, one server can handle multiple websites. So you go to mysite.com, it by default, Apache's website configuration is going to look for the index file. And if you give it a path, say /img/logo2, well then it's going to look at that path and say, well, does that file exist? Let's see if there's an img folder. Let's look in that img folder to see if logo JPEG exists. Hey, it does. Let's send that back in the response, and since that's a JPEG, we're just going to be smart enough to give it a content type of image/JPEG. That's your basic Apache setup. It's going to automatically grab you files, and it's going to automatically set content types for you. And you can configure the content types that you want to return. So that's kind of your basic website setup. If you get a website and you're just building content for people, that's what's going on. Let's look at something more complicated. So Clearly, Twitter doesn't do this. Twitter has to manage users and tweets and all that stuff. They're not just handing you a JPEG file. How does a bigger company handle these things? So they're running what's called a web application. A web application server is set up a little bit differently. So you've got your web application itself. This will be Ruby on Rails, or this will be, if you're PHP, it will be Laravel or CodeIgniter or Node.js. This will be .NET. Your web application right here is set up to respond to stuff. So let's say your web application is also listening to port 80. Let's say I've configured this to listen to port 80. So now I'm going to get, when requests come to my IP address from this machine, this web application will pick up on them. Haha, what are they looking for? They're looking for twitter.com. Okay, twitter.com is not, my twitter.com homepage is not just a homepage. It's not just an HTML page. It has all the tweets baked into it. So what I'm going to do is I'm first going to go to my database, which would be like MySQL or MongoDB. Give me all the tweets from this user's timeline. And now I'm going to go get my template. I'll have what's called a template, which says, it looks kind of like HTML, says head, body, but then it also says for each tweet, spit out this piece of code and put the tweet's information in it. So then I'm going to template that together, and then I'm going to send that template mixed with the tweets as a response. I'm basically going to generate HTML on the fly, send that as my response back to the user, and I'm going to set the content type as text/HTML. So as far as you're concerned, the user just gets HTML, blah, blah, blah. They don't care how it was made. They don't care what framework made it. They don't care if CodeIgniter made it or if Ruby on Rails made it. The browser just says, here's what I got, and the header, the response type, is text HTML. So as far as I'm concerned, you gave me an HTML file. I'm going to spit out an HTML file. And so that's kind of how a web application server works. If you request, it's also smart enough to know that if you request /images/logo.jpg, that's just a file. I can go grab that from the file system and send it back with a content type of image/JPEG. And so it also will reply to JavaScript requests. So say JavaScript makes a delete request, delete tweet ID 1. Then your web application is listening to a request on mysite.com/delete/1. So, or /tweet/1, delete request on that. So if I send that request in, delete tweet/1, it knows, aha, that's got a method of delete. So I'm now going to go find it in the database. I'm going to send a delete. Boom, you're out of the database. I'm just going to send them a 200 OK. No content back, just a 200 OK response, absolutely no content back. JavaScript can pick up on that and say, woohoo, we deleted it. And then JavaScript can make it go poof from your web page. So that's kind of how your web application server has. You're going to manage 3 different things. You're going to manage templating of stuff and generating HTML on the fly. You're going to manage API, which is JavaScript talking to you. JavaScript says, delete this. I don't need HTML back. I just want you to delete this tweet and tell me it was done. Okay. So, okay, delete request to this, delete it from the database, it's gone. And it's also going to handle static assets. It's going to handle serving up of images that never change. You request this image, I'll hand it back. You can break this up into 3 applications, one just for the HTML, one just for the API, one just for all the logos. You can do a million different things with it, but that's kind of how everything goes in the web application world. And so let's say what happens when this server starts getting so overloaded because your website is so popular, it can't handle it anymore. Well, you got 2 choices. You either upgrade to a more powerful machine with more RAM, more processing speed, all that. And that will get you by for a short term, but you're going to run out eventually. Google and Twitter can't run this all on one big pimped out laptop. They need something more powerful than that. So what you're going to do at that point is you're going to, let me see if this will work. Okay, that got ugly. But what you're going to do is you're going to then run multiple copies of your exact web application. So this is on its own 6.3.45. I'm just making something up. This is running on, say, your .2 box. It's its own machine with its own IP address. This is going to be its own machine with its own IP address. And this is going to be its own machine with its own IP address. And then, let's see if I can pull this out here. Boop. Gotcha. Then you're going to actually, this will be a machine with its IP address here. And you will run a load balancer, which sounds complicated, but it's really not. Let's just make some up. 3.4 dot, I'll say .1. So this, your DNS for mysite.com points to your load balancer now. So you go mysite.com, DNS points to here. This guy is going to keep track of how each of these guys are doing, and he is going to real-time send traffic to each box, each web application in the box. So if you've got your first user will go here, your second user will go here, your third user will go here, and then depending on how this is set up, different load balancing programs handle it different. Some will always go 1, 2, 3, 1, 2, 3, 1, 2, 3. Some will keep a track of who's the busiest and send people to the server that has the most capacity. So then it's called scaling your website. Then say your users are getting more and more and more, you just add another server in there, a .5 server. Configure this guy to also have a .5 server that he processes requests to, and boom. And so then you just keep adding servers on. And you have to figure out at that point a deployment process. So how do I actually send this code to all the servers in one command? And that can get a little fun. But that's basically what the back-end side of things looks like. I probably covered a ton, especially if you're new to web development. This is a lot of information. But that's basically what the back-end side of things looks like. And now you're free to start messing with the server technology. Ruby on Rails, Node.js, PHP, Laravel, whatever you want to get into. Now you're free to get into it. I hope this was a help to you. And if you have any questions, stuff that just isn't clear, feel free to leave comments below. All right, have a great day.